This find the adjoint of the matrix A. So matrix is given, we have to find out the adjoint of this, and also they are asking us to verify the theorem that A into adjoint of A or A adjoint of A or A into A equal to det A into this identity matrix. So let's see how to find out the adjoint of a matrix. This is a 3 by 3 matrix, right? So let's see before how to find the adjoint of a 2 by 2 matrix. Let's say I have A, B, C, D. So I told you that if this is a matrix, then we are supposed to replace every element with this with its cofactor, and then take the transpose of this. So I am forming a new matrix which is nothing but replacing every element with its cofactor. What is the cofactor of this one? You remove this row and this column and then find out the determinant of the remaining. Here only one element is remaining, which is D. So D. And moreover, in this cofactor we don't get minus because the indices of this are 1 1, therefore minus 1 power 1 plus 1 is positive. So I am not going to write minus D, it is simply D. And what about the adjoint of B? Remove this row and this column and whatever is remaining, C, right? And now check this sign. So the indices of this is 1 comma 2, first row and second column. Minus 1 power 1 plus 2 is minus 1, therefore minus C, right? And what about this one? The adjoint of this cofactor of this element, you remove this row and this column, it is B, but then it is the second row and first column. So minus 1 power 2 plus 1 is minus, so I am putting minus here. And what about the cofactor of this? Again the same thing, remove this row and this column, what is remaining? A, but then it is 2 comma 2, therefore you need not put minus. Got it? And now you find out the B transpose, which is nothing but the adjoint of this matrix. So what is B transpose? B transpose is D minus C minus B, then that A. This is the transpose of this. So this is the adjoint of the 2 by 2 matrix. Got it? That is how we get it. So now let's see how to find out the adjoint of 3 by 3 matrix. The same way, I'll take cofactor of every element and then find the matrix B and then take the transpose of it, which is going to be adjoint, right? So watch it. Now A is this matrix. Okay, I want to find out the adjoint of this. So what I'll do is I'll find out the cofactor of every element. What is the cofactor of A11? Cofactor of A11 is obtained by removing the this row. I want to find out the cofactor of this one. Remove this row and this column. So what is the remaining elements are here. Now find out the determinant of this, which is 3, and then 1 1 2. Again the same thing. So remove this row and this column, this column and this row, and take the determinant of the remaining elements. But then here you get minus because the indices are 1 2. So minus 1 power 1 plus 2 is minus 1 power 3, that is why minus 1. Similarly, we can find out all the cofactors. Are you getting this? How can I find out the cofactor of 1 3? A13 is this one, right? So remove this column and this row. What is remaining? 1 2 2 minus 1, 1 2 2 minus 1, and find out the determinant of this, and it should be multiplied with minus 1 power 1 plus 3. So minus 1 power 1 plus 3 is plus 1. So it is, I'm not putting any sign, minus sign here. It is minus 5. Okay. Likewise, you find out the cofactors of all the elements of the matrix A. Once you find out the cofactors, then you form the matrix B. B is nothing but replacing every element with its cofactor. Once you replace every element with its cofactor, then you take the transpose of that matrix B, which is nothing but edge A. Then I got, this is it, adjoint of A is this. Then you can verify that, you can multiply this. You can take A and multiply with this, or you can take adjoint A and multiply with A. You are going to get this as the answer, which can be written as minus 11 into this. Even if you find out the determinant of A, you get that determinant is minus 11. Therefore, the theorem is verified. What is it? A into edge A into A is this. Actually, I didn't multiply here. You can multiply and see that the result is this. You can check it for yourself. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So First reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.